Hello ladies and gentlemen, welcome to another video on this channel regarding the Minuteman machine. So my plan today is to 3D print a Benchy in less than 90 seconds. This will pretty much shave off 30 seconds of this existing record, but my prediction is the resulting Benchy, and we're coming to that in a second, will look like crap. So let's try to use all our knowledge that we've gathered in the previous episodes and try to dial in a 90-second Benchy as good as possible quality-wise. My name is Jan, I build stuff so you don't have to. Enjoy the episode.
Da 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 da.
Alright, let's start with talking filaments. As you can see here, we got 4 spools, 4 inlets here on the hot end. And today we're gonna try to make use of our co-extrusion technology here. Because while we're feeding 4 filaments into this massive heating block, the question is, can we combine properties of different raw material? You can see here on the left, this is some Benchy, I don't know, it's number 35. Which is printed in standard PLA, and this is printed in ABS. And what I noticed throughout my filament testing series is that ABS does have a lot of potential in terms of speed printing, but what the ultimate limitation is layer adhesion. You can hear that, right? But essentially we're using shop air, and since it does a lot of expansion when it exits the nozzle, it will be pretty cold. And in the previous tests I also had like this container here where we put in like dry ice or liquid nitrogen to enhance our cooling capabilities even further. And this doesn't really bond with ABS or ASA technology. Well, basically if the filament is coming out of the nozzle, it needs to contain enough energy to remelt the already deposited layer below it. On PLA, on the other hand, this isn't turning out to be a problem. See, it isn't the prettiest one, but no matter how hard I push, I can't separate these layers here. And today we're trying to combine the best out of 2 worlds and put these filaments into our system. The most outer ones are PLA, which will form a shell with the idea of having a solid core from ABS, and all of this is surrounded by a soft and very viscous PLA. And PLA has very good layer bonding, so my idea behind this is we're going to create a very stiff core that's going to suck in all energy from the shell material, and the shell material itself will always have enough energy to bond to the already deposited layer. Let's see if we can find any parameters that will work with something like a 1 minute 30 Benchy. Alright, so the filament is loaded up. And I just had a first peek in extruding this material. So I gotta admit, it's at least 2 months ago since I did the last print on this machine. I've been very busy with other stuff you will see somewhere down that video, I guess. You know what? Let's actually do this right now. So this has been the very first printer I upgraded with one of these SLM printed Hotends. In case you didn't know, I am building an open source hot end that does all the crazy things you have never seen before. This is the second machine I actually installed this on. This is my 2nd generation of hot ends. And while all of these do feature enormous kinds of flows, this was chilling at 200 cubic millimeters a second. I'll put a very short clip on here. This does not just as much, but it does all sorts of funny things with multicolor printing. So what I did with both of these machines, there will be the next and upcoming video is going to be about hot ends again. And I will show you exactly how to run these hot ends on kind of these machines here. This has been updated with Clipper on a external Raspberry Pi, and this is connecting with just the standard Creality mainboard down there. And this has been working really flawless. I did some really big prints with it, and also, come on over, have a look at that. So there are a few prints. All of these are done without any AMS, without purging, without rainbow filament. And I don't want to give too much away, but have a look at this here. Again, no AMS, no poop, no priming tower whatsoever. You can have this on your printer in the next few weeks. So I think it would be a great opportunity to actually maybe consider subscribing to this channel and at least have a look at the next video I'm releasing. As you can see, we're getting a little bit of dye swell here. This is a 0.5mm nozzle. The filament distribution is 50-50, but as you can see, this is clearly way more blue than it is burgundy colored. And this looks as usual with this Hotend. See, this is not designed in a way that this co-extrusion is possible, but it somehow ended up like this. And we don't have a perfect wrap. It is like 70 or 80% of the outside is being covered by the PLA. You will always have these short segments sticking out as of the core material. But in a deposited way, this is not visible. Jesus. So these are the prints I managed to do yesterday. As you can see, I had to deal with a bit of bad adhesion problems at first. I guess my ABS jizz on here has been contaminated with fat from fingers, etc. But as you can see, performance-wise, this is not the best. I'm able to produce way better looking benchies in half of that time. This has been running 3 minutes 50, and you can see that we do have some severe issues here. But the biggest thing I'm concerned about is have a look at these different sides. So I've been seeing this before when I was just extruding free air, that we do have some uneven melt. Can't really find the issue here, but for the kick of it, I'm just going to extrude some material here. This will be coming out as somewhat 4mm diameter. This is at 150 cubes, by the way. And as you can see, it dangles around a bit left to the right, depending on where it actually does like stand off to the ground. But in the essence, it's coming out straight in here. But I think I know what's happened. So when I was like setting this back together yesterday, at one point the whole assembly fell down, and I guess what happened is that the nozzle here is like being squished inwards. The problem now, this is my last 0.5 I have on shelf. I have to order new ones. I tried to grind down the top, but the damage is like going way further inside, so I can't make this run properly without messing up any other parameters. So for now, we're gonna stick in a 0.6. So let us just put that in here, gain some more experience. For today, we're gonna have to live with this one. This is 150 cubes at 180 degree, by the way. It does come out straight as an arrow. So it was definitely the 0.5 being dented in. Yeah, so fixed for now, I guess. Okay, and I thought while we're at it, let's talk a bit about what has changed on the machine since the last video. Starting off with the cooling situation. This has been the cooling duct you've seen on the last video. This is being manufactured in stainless steel. It did work out not quite as good as I thought. The previous one was prototyped in this SLA printed high temp material, which worked a bit better for reasons I can tell you. I can show you now what the problem with this is. So I got my CFD engineering stick here. I'm gonna turn the duct on and you will see where the thread is being pushed to. So as you can see, when the air exits, there is a clear tendency to walk down here in a very shallow angle. And I actually do have captured a slow motion shot where this is clearly visible, where essentially the bridge that has been applied up there in the front is pretty much where it is supposed to be until the printhead reaches the opposing side of the whole benchy section up there and blows the bridge right away. This is when the stream of air actually hit it. And this caused some very uneven behavior in cooling, etc. That's why I could always see that one side is being cooled better than the other. Yeah, and I think with the new iteration we're gonna have that sorted. Because this is pretty much what I'll be putting on here on the machine. As you can see, it's pretty much the same style as before in terms of the opening geometry. There's still an air knife that feeds the air straight below the nozzle tip, and then it creates something like a vortex going on here that is evacuating the zone. To get a better distribution and pressure, I designed these two air inlets here coming from left and right, and these do form a secondary outer chamber where we do have some expansion of the air going on and everything can normalize, and then there are about 80 small holes somewhere in the range of 0.75 millimeters, and these do point straight at the nozzle. In this case, this is the, I don't know if you can read it, this is the no vortex version. So these holes are pointing straight toward the nozzle. I got a different set which is offset by 2 millimeters, so essentially the stream of air will hit slightly above the nozzle and then on that side slightly downwards, with the hope of creating a spiral. And with the help of my CFD stick here, I could pretty much prove that there is something like this going on. So let me put that on the machine and show you the difference it makes compared to this stainless steel one. Okay, so new duct is on the machine. Gonna turn on pressure, same pressure as before. And yeah, as you can see, this one is going down pretty damn straight. It has a very slight tendency to walk over to the left, but I guess this is mostly because this is becoming somewhat flexible when it's in constant contact with the nozzle heater up here, and therefore the whole system pushes it into a certain direction. And of course the evenness of that gap here is crucial for whatever the air is doing at the outlet. But let us run this in this exact configuration and see what happens. So yeah, last but not least, before we had on this Big Tree Tech Pi version 1.2, and I changed this to an original Raspberry Pi 5, because I was guessing that I could get out at least a second or two with just these components being switched. The Pi 5 is way more powerful in terms of CPU, etc. I have no real idea if this ever becomes a bottleneck, but I wanted to make sure. Yeah, and also, because I was doing this, I have switched over to Calico. And if you've never heard that, maybe you've heard of Danger Clipper. It's essentially a clipper derivative that has been added with loads and loads of special functions that yeah, enables you to do stuff you can't do with a clipper. And I'm just getting used to it. I have installed very limited extra forks, but I have been fooling around with a TMC auto tune and some other stuff. Also, I'm very keen to use the MPC controller for temperature on the heaters. So I'm still figuring out all these systems, and once I got very used to it, I will do some more explaining, but I need to figure it out all by myself first. So let's print something, I guess. Okay, very quick chat about the filaments I'm running right now. I've shown this one before. This is the co-extruded one with PLA on the outside, ABS as a shell. This didn't look too promising, but one thing I can say that my theory of the strength is working out. So I just got one hand, but I'm putting a lot of pressure on here. It's a really stiff guy, and it has been cooled. If I had just a regular ABS print being blown cold by that amount of shop air, this wouldn't be holding up these kind of forces. So this theory is proven, at least. But in terms of, yeah, I haven't run this machine in quite some time. I need to get back on track. Every percent is counting if you want to go like sub 4 minutes or something, and this is nowhere near where I have to be. For a comparison, this is just plain PLA, so 4 spools of high-speed PLA by Fiberlogy. This is looking way better, but as you can see here, this is the line where it does try to fill the deck. So it has a longer layer time, as well as here there's a sudden change again. This is much more visible on this filament here than the one I used before. So Fiberlogy sent me this stuff. This is the same high-speed PLA, but not in the transparent version. Apparently this has only been produced for me to check it out. And I want to check it out. I mean, it does work pretty good, but I'm gonna switch back to the transparent one to see if I can like get variables out of the way. I want to use the transparent one to actually compare these ducts down here. So I'm gonna change the filament to this and then stick with this for quite some time, I guess. So usual and transparent version, I had a pretty good look at both of them, and they are looking pretty much exactly the same. These little things, you can find the exact same ones here. So because the artifacts and problems are way better visible on this one, I'm gonna change back to this here. I think we should get the same results here. So I got the feeling this will be one of the videos that will like jump around all over the place, because that's what I'm doing here as well. But yeah, I got something in the mail. These are 0.5 millimeter nozzles. I'm gonna put them on the lathe and yeah, rework them so they work with my cooling duct, and then we'll upgrade the 60 volt power supply because this turned out to be a limiting factor. And yeah, then we'll meet again. Alright, let's have a look at a few things I've changed. So we got another 0.5 millimeter nozzle installed on here, so we can get back on the like speedboat race rules, etc. While we're on the subject of here, I upgraded this cooling duct of the pneumatics behind it. So I don't want to show you this mess, but I upgraded this line so we don't have like that 6 millimeter spiral hose all the way to the machine. This is a, I think, 1/2 inch inside diameter tubing, so no restrictions there, and it's gonna feed into this magnetic solenoid. So as you can see, it's going fully in here without any restrictions, and then I upgraded to a double 6 millimeter OD tubing, and I got rid of that T up here, so full power on this duct. This is a massive upgrade in terms of just raw flow. I have no idea if that actually does help, but in all like previous tests, it seems like we're still not saturated in the amount of air we put on there, but we also get a lot of downsides, like more downwards pressure. Last but not least, I upgraded the power supply. This is pretty much the biggest one I could get in terms of these switching power supplies. This is a 60 volt 20 amp unit. I upgraded from a 60 amp 16 amp unit. I've been running these steppers for pretty much all the time in 2 amp mode, and now with increasing acceleration I need to up it a bit more, and with 2.5 amps they did cause some flickering at least in the voltage here, and then that ultimately led to an error on the Kraken mainboard. Now I think I want to run them in 3 amps, and I think this could just match out. So 4 times 3 amps, and then another 2 amps for all of these, so 1/2 amp for each motor, and then another 2 for this one. So this is pretty much, if all of them are running at the same time, it's pretty much maxed out. So I gotta see, I want to have it as consistent as possible. If there is any signs of errors in the, that it throws an error sometimes, I will go down, then search for another supply, because in earlier attempts I had 2 of the 16 amp versions and I could like hook them up to individual drivers, but it's not possible on this board. So the next step from this is, I don't know, some real industrial power supply, or either we're gonna build some crazy capacitor bank or something. I don't know. Let's see if I can maintain 3 amps on all of these motors. If that works out, I think I have some pretty crazy acceleration values I'm gonna show in a sec. Okay, I have decided to just gonna wing it. There is 200 G of acceleration in there and 1500 millimeters per second printing speed basically on all moves. I have no idea how that is going to look, but in order to like dial everything in, we have to first set some references, and this is the basic speed we want to go. Let's see if this machine can pull it off repeatedly and reliably, and then we can like dial in all the little things. I'm just gonna wing it. I think we might have a chance that this runs through, but we'll just see. There's only one way to find out. Here goes nothing. Oh. So it didn't run all the way until the end, but I'm counting this as a 100% win. This, and I've dry humped this G-code before, would have finished in 1 minute 29. And as you can see, of course, as always, there are defects, but have a look at some parts of it again. Like here on that. This is going full blast, 1500 millimeters a second printing speed with 200 Gs. Let me rephrase that. 2 million millimeters per second squared accelerations. And the reason why it didn't finish are basically two things. So first of all, basically I've been running this shop air system for like all of the time. But with the added throughput of the newest like base pneumatic fitting situation there, it was able to suck up a lot of moisture that is trapped inside my system here. And I tried to film that. I don't know if you could see it, but on this transparent part you could see moisture building up inside. And it was throwing quite some at the print. And then of course, temperature control is off and it didn't stick, etc. But basically at the same time also I got error from the Kraken board because there was undervoltage happening. This guy here couldn't deliver the power, so I have to dial the motors back a bit. We were at 3 amps now. Let me try 2.75 and let me first do a dry run and see if we can finish without losing steps. I think the motors itself aren't a problem. I could pretty much run them back to back. But then if the heat travels into this nylon part and surpasses something like, let's say 100 degrees, I'm gonna lose them and then I'm gonna start all over again with calibration. So I'm gonna make some pauses here. And while we're on the subject of pauses, let's take a second to thank our today's video sponsor, which is PCBWay. So PCBWay has been a long-time sponsor of this channel and especially project. These are SLM 3D printed from solid aluminum and these pulleys have been polyjet printed from nylon. And for their weight, it is absolutely mind-boggling how these are still holding up with the 200 Gs of acceleration you have seen in today's video. This is just absurd. Acquiring parts is really easy. You just hop on their PCBWay website, upload your files in whatever format you have them on hand, select the various processes, for example CNC machining up to 5 axes, PCB manufacturing or 3D printing in all sorts of flavors, hit go and you get an instant quote. So thank you PCBWay for sponsoring another episode. Let's get right back to the content. Have you heard that? That was definitely a step loss, but I was pretty fast on the emergency stop. So 2.75 equals step losses, 3 amps equals error message because of undervoltage. Let me think about that. So this wasn't a skipped step. This was epoxy carnage. Well, yeah, of course, these accelerations are putting a lot of stress on all of these connections here. Let me see how I can fix that permanently. Yeah, so apparently we're back in a region where I'm running some of the parts here at above 90%, which I'm not very comfortable with. This was the last I did print. It did kind of look pretty fine up until here, and then we had a skipped step, so it's a very thin line between skipping steps causing undervoltage here and, well, now with more attempts with overheating. So I've been using some dry ice here on the drivers. But I'm kind of seeing right now that I have to actively cool this in the future, as well as the motors. So they are good for a run or two, but then they are quite warm. And with a setup before with just 2 amps, I could just run them back to back pretty much with the whole setup here. So I've changed a few things here and there and had a few dry runs that were looking pretty optimistic. So I hope this will like stay forever for one attempt. I just have this one left today. So let's see if this runs through. So 3 attempts, something in the neighborhood of 200 Gs, 175 Gs, 150 Gs. But apparently they all had like skipped steps at pretty much the same height. So there has got to be something in the G code, like I'm pretty sure he wants to do that part here where like this backside of the boat is being attached to. Maybe it is like catching on this or something. I mean, the infill doesn't look properly good, but you can't really tell because after these skipped steps, I don't know what was first and what came after. But yeah, I have to do some more investigating here. So it's the next day. I've been fooling around a bit with high-speed footage. My plan was to just print the lower half and see where we get like step losses, etc., and hit record at the exact moment it happens. But the last 2 prints pretty much ran through. First one did release from the build plate, however, but second one is this guy here. But yeah, the second one is actually the first 1 minute 30 on the dot that finished. And this is still attached, and this here is my last print. So let's examine that a bit. So this is print 135, and this one did loosen up. I messed up the temperature of the first layer, it was too cold to stick. And the main heater body was at 180 degrees. So this has been looking like, to me at least, that we do have not enough melting capacity down there. We're extruding in this region here at 190 cubic millimeters a second. Apart from that, of course, my pressure advance settings are way off. This is the seam line, and then of course, who would have thought cooling is an issue. Then on print 136, I raised temperatures on the main heater body to 190. And as you can see, it got a whole lot better. Right here, this is the heaviest line of extrusion. It has to do all that surface flooring here. And this is without any delays in extrusion, so we're pretty much continuously extruding 190. I could set my Hotend just to 220 or something and it would maybe do 400 cubes, but then we're extruding way too warm of a filament and we have to cool that down again. So of course we need to find some compromise here. Maybe I also have to heat tune the main heater body, but from here to here is literally just 30 seconds. I guess we won't draw enough energy out of the system to get it down to, I don't know, 170 or something. And then again, right here on top, we need again 190 cubes. So I guess I have to leave that untouched and yeah, do the rest with software. But I think this is a success. This is literally the first 1 minute 30 Benchy out there. And I've seen worse that are like 4 times this speed. I do have some 1000 FPS footage of this top section here. You can see a lot of things going on. This is wobbly. The main reason, except for, of course, in this case 150 Gs of acceleration, is that it's not properly connected down there. You can see the layer adhesion is pretty good actually, but the surface down here, the boat's deck, is not fully like engaged with all these pillars. So these have been flopping around quite a bit, and I've also seen that I have a lot of material build up at the cooling duct, which seems to be dragging stuff around. So I'll get rid of that. Yeah, let me see what we're gonna do next with these. So you just, I hope you saw print 137 and 38, and these are all pretty much the same values in terms of slicing, but pressure advance, I did go a bit up and down. This is 0.1 as I had before. This is 0.12 and this is 0.08. So you can see how much that of a freaking difference makes. So the lower value seems to be more in the right neighborhood. So I'm gonna go with 0.06 in the next iteration and see where we end up with this. On top of that, I fooled around with some other things. For example, this chimney does look way too good in terms of the rest. I gave this a bit more speed, actually twice, but pulled out a bit of layer time here. So this was at 0.3 seconds before, and now we're at 0.33 seconds. Let's rerun that. Okay, next in line. So I think I found some parameters for pressure advance. This is not the best one of them all, but the latest I printed. And what you can clearly see is that all these parts here do look pretty fine. I mean, for the most part. But of course, the pillars are our biggest problem. So what I did is I gained some speed down here by setting the layer time even lower, 0.3 again, and set a manual modifier up here in this section with a fixed speed. I hope that I can give this layer times of 0.5 seconds or something, because this top doesn't look actually too bad, but of course it doesn't have any support below it. I hope by having this modifier in here I can support these pillars up to the top and give the roof somewhat to stick to. Let's run that. Okay, this is my latest one I've printed, and see one side, other side. There's clearly a difference, and I've noticed that before with uneven pressure on the cooling duct. And this is the one I've pulled off the printer. I've seen this one for quite some time, but I want to keep going. In case I crash it, I only have just one replacement, which we'll put on now. But also there's this chunk missing, and I think the whole like surface geometry here is distorted. This is the one we are going to be replacing it with. Both of these are printed here on an SLA printer in high temp material. But we're also going to like change a variable here, which I'm not very keen about, but all of these holes do line up 2 millimeters to the side and therefore should create something like a vortex down here. I'm gonna put this on. I hope I don't mess it up because this is like the last one I got for now. And I'm also missing replacement resin on this type, which is quite expensive. So I'm gonna put it on here and rerun the last test to compare these two and see what the actual difference is. So just that I have it on the same video file, finished in 1:29. Okay, same G-code, same everything. This is the old duct. This is the new one. I think I'm on the right track here. On the one hand, I'm making real progress. Have a look at these beauties here. This is still on record pace. But then I had twice skipped steps right here at that section. So I'm pretty much right back where I was yesterday. All of these prints have run back to back without any issues. But yeah, I seem to have encountered the same problem I had yesterday. I think what's happening is that some of these extrusions here stick out and the nozzle is catching on there, I guess. That is the only thing that I can really think of. So I think I'm gonna go back to what I was planning today, capture some high-speed footage of that exact layers here and see if we can derive anything from that. I will put you in, this is 1:49, a slow motion of that part here with the deck surface. This is still 1:29 pace, and I think we're right where we need to be in terms of the hull line. Have a look at that cooling performance here. This is just insane. But yeah, I don't really know how to get rid of these step losses, and step losses is a big thing for me because on the one hand I might destroy my machine with it because it's like banging aluminum to glass in that case. The more important part is all these prints I could do in like with 5 minutes between them to cool everything down. To set this up, the winch kinematic doesn't have a homing routine, at least I couldn't come up with one. This is pretty much like 20 to 30 minutes of work to get this all dialed in again. So my iteration speed is way down when I'm having step losses. I don't know, I have to figure that out before we go into even more advanced stuff. Okay, I'm back to dry running the system and maybe find out a bit more. I do have these strings here, the resonances they produce. Maybe this is a lead to why it is skipping steps, because this is bouncing all around at certain speeds. And I put in these screws here to hopefully counteract these resonances a bit. And yeah, extruder and Z-axis are offline, so let's run something without air, etc. So just as I thought, it has run all day, even with those resonances, and I mean the prints actually, well, try to find those resonances in here. I think this is not the issue. This has got something to do with the print itself and the previously extruded lines where it's catching or something. I don't know. Well, so how was that with the definition of crazy? Actually repeating tests multiple times and expecting different results? I have time for one last test for today. Let's just rerun it and hope it will make it through. Got to be kidding me. Yeah, you've seen it on the video. This one ran through. So basically and technically, this was the prettiest and fastest benchy at that time. But a second later, I had like over temp error and the Z-axis fell down. The chimney was actually looking not too bad, as I mean it's the same code as before, so no cheating here. I think I found my pressure advance values. I think this is above 80% of dialing this in at that speed. I also did measure the weight. It is supposed to be 8.74 grams and we're at 8.9, so I pulled another 3% out of the extruder, which is 3% less to cool. Actually before, these guys here were under extruded. I just found that out of curiosity. I didn't change the temperatures, I just upped the amps on the extruder motor. So see, this thing is just ridiculous. As I said, this is running at 180 degrees on this Fiberlogy high flow PLA. Throughout most of the print we're asking 190 cubes of filament, and all these motors before, because I'm running very low on my power supply, all these motors were at 0.25 amps. This is just ridiculous. This is Friday now. I think I have to call it quits for today. I do have some dry ice left here. I have no idea if this will still be there on Monday morning. I used this throughout the print to cool down the heatsink of the Kraken board, and actually I think the error I was getting was due to over temperature. And then maybe I teased it at the beginning, but look what I have here. This is helium. It's a 10-liter bottle at 200 bars, so we have exactly 2000 liters of helium to play with. And as soon as I'm confident that this system will run through and make it again back-to-back passes, we're going to be switching our cooling media from shop air to helium. My prediction is I'm gonna give it everything. So this is tops 2 Benchy prints. This bottle cost me 150 euros worth of helium. I want to be sure that it runs through. And I mean, this is a perfect opportunity to thank all of my patrons here, which kind of enable me to do all this silly and funny stuff for science. Actually, running helium is extremely wasteful. I am all about upcycling, renewable energies and all that stuff. I hate to throw trash away or use this basically as trash. But for science, we're going to do one run to see what the differences are. And if this could enable us to run the sub 1 minute Benchy, we're getting increasingly close here. I think what I'm doing now on the motors is just the beginning of it. I'm running 3 amps only. The board can do 8, but cooling again on the TMC drivers is an issue, and I'm running out of power supply capabilities. But there is a lot more headroom, and maybe if we ever come close to running it at sub 1 minute, then this might be our last chance to actually cool it, because extrusion-wise, I'm extremely confident this is no problem. The Hotend will be able to deliver that kind of flow. So let me see what I can come up with in the following days. Alright, let's make a long story short. Unfortunately, this video has to end right now, because it only makes sense. So I was getting back on the machine on Monday, and pretty much in the first attempt I wrecked this guy. Then I tried to reprint it on the SLA printer, but the resin tank is pretty much just empty, and I had 2 failed prints where basically resin was missing. So in summary, I don't really have all the things lined up here to make this a proper test. But still, we freaking printed a 1 minute 29 3D-Benchy, which is not looking out of this world bad. And this has been the 20th print I did on this speed, so I know there is a lot of headroom. One of the biggest things I found out during this episode in terms of improvements is this duct here. And it is not only this duct, I mean, this works pretty good in terms of flow distribution, etc. But I would have never thought that the amount of air that is traveling through here is making such a big difference. So upgrading it to not have any restrictions in the system was kind of a game changer here. I would have never thought that a 129 Benchy would look something like this. If you are speed printing as well and want to have these files, come on over to my Discord. Of course, I'm willing to give these away for anyone that is in the same rabbit hole of trying to print better and better and running into the same issue with cooling. So as I said before, I'm gonna be switching back and forth between the Minuteman project and the Hotend project, which is kind of derived from the same initial project. I do have very solid plans here on the Minuteman machine to go down. We want to focus, the next videos will be about breaking another barriers. So next one will, if you see a video of me releasing titled something with world record, we're gonna have at least the 1 minute 19 broken. And I think with the plugins I'm using right now on the machine, I'm kind of limited again. So I have to get in the game of the whole Calico thing and have to dial the motors in perfectly before I try to run another test and spend way too much time on there, because I need a solid foundation where I can run things back to back and make tiniest amounts of changes, because at the level we are at right now, the tiniest amount of changes in any of these variables do make all the difference. I am really hard at work keeping both these projects going. The Hotend project did take me a bit longer because I'm facing some legal issues right now, and I don't want to get myself or anyone else into trouble by using these. But I think at the time this exact video here is being released, this will be sorted out and I can work on the final version that I will bring out to you guys. So it's just a couple more weeks until you can finally get this thing on your way. And then we'll have full build documentation, etc. As you've seen in the video, for a couple of seconds this had a working and good looking chimney actually on top, so just imagine it would have been there. Please put everything down in the comments, what you think about this process, what you have learned, what you want me to do in the future, what I could be doing with the helium test as well. Maybe I could do it way more intelligent test with your help. Put everything down there. My name is Jan. I build stuff so you don't have to. See you on the next one. Bye.
You